Next speaker up is Helen Rowe, Dr. Helen Rowe, our ecologist out of NAU, talking about long-term monitoring in the preserve, keeping the pulse on the preserve.
So I'll be talking about our biodiversity projects. And here we go. Let's see. So here's the diagram Jesse just introduced, where we think about our management action. So I'll be starting about focal species and groups. So we have, as you saw earlier, this is our list of long-term biodiversity monitoring projects. I'll be talking about these ones, and Melanie will be touching on these ones a little bit later. I'm gonna, for my intro, I'm gonna be giving a quick overview of some analysis that we've been working on just this year on arthropods, and give a light overview of things, and then introduce Bradley for the butterflies. So we have been working with partners Derek Huey and Rich Hostetter at NAU, and also Stephen Earle at ASU, who's been our long-term research partner at CAP LTER. And we've also been working with the citizen science lead, Jerry Holden, and our current Joanne Goldberg. So this is the setup of our arthropod studies. We've been conducting these, and it's escaping me now how long, but we have several years of data dating back till 2014 maybe. And here's the way it's set up is that we have interior sites and exterior sites in 4 places on the preserve boundary. We also have these 2 that were instituted for a couple of years as extra interior sites. I'm going to delve straight into a few of the interesting findings that we found. So here is, I'm going to show you, these are different ways of looking at arthropod diversity. And so here's a plain number of species. This is a Shannon's index. So this talks about diversity. So that includes some other items. And this is another diversity index that includes kind of evenness, how balanced are the species. But basically, these are just different ways of lenses through which you can look at diversity. And the interesting thing to look at, let's see if we got pop-ups here, is that for several of the sites, we would see a difference between the interior, which is blue, and the edge site. So these are the locations in the preserve, and blue is interior and orange is edge. So here's a difference in which the interior had more species than the edge site. Here's another one that had the same pattern at Tom's Thumb. Another, again, a different way of looking at diversity, again, at Gateway, and again, at Gateway for this other diversity index. So those are the main ones where interior was greater than exterior. But we also found a couple significant interactions in which we saw the opposite. For example, Lone Mountain with the Shannon's diversity index, and also with the evenness index. So that was at Lone Mountain. We also found an interesting trend where our interior sites were also quite different from each other. So digging into that trend a little bit more, we had, here is on the y-axis, we have, I'm not going to go over all of these, but basically this is an overall abundance of our arthropods. This is a LPT, which is least practical taxonomic unit, because arthropods are very difficult to get down to species, and so sometimes we just get them down to genus or maybe above that. And then we have ants and beetles and bristletails and fire ants and mites and spiders and springtails and true bugs. So all these groups of species. And the thing to note in this is that there was an interaction in abundance where in the spring, the interior sites had greater abundance than the edge sites, but then in the summer that switched. So we can see over here, this is what's causing this, was ants and mites, in which in the summer they had these very big abundances of mites and ants, and we had enough resolution and identification that we were able to see that it was actually caused by fire ants coming in the summer. And so our summary take home was that there were differences between interior and edge differed among sites, but there was also, these were mediated by seasonality. Invasive ants were more prevalent at the urban edge and increased with temperature, so in the summer. Another thing that I didn't show any graphs for was that precipitation favorably affected pretty much everything. All of the arthropods did better when there was more precipitation. So bringing this back to our adaptive management, when we think about, when we look at this, our arthropods, we see some of the results, and the results are that, oh, look, we are having more fire ants in the urban edges. We can start to, we're just sort of getting through our analysis, but so we don't really have an idea of what that management action might be yet for fire ants, but that might be something that we can think about. Another thing we can do is think about maybe a targeted question about fire ants or the mites that might help us learn more about what we can do about this invasive fire ant. So now I'm going to quickly change gears and give you a couple of quick updates on birds and plant phenology. So with birds this year, we've been working with new database collaboration, and Doug talked about the crew that we had moving some of our bird data into a new IB8 database. We also developed a new butterfly database where we've been adding data to. And these databases are going to make it much better for us to be able to visualize and summarize our data. And so this next year, we'll be working on looking at our sensitive species and creating some summaries about those so we can learn more, analyze our data that way. The other thing is plant phenology. We did some preliminary analysis last year, and we'll be bringing that forward next year. That's going to get some attention. Bats, we've obviously been doing a lot of analysis on that, that Jesse mentioned, so I won't mention that. So that brings us to butterflies. So as many of you must know, we're experiencing unprecedented rates of extinction and loss of biodiversity. And so this sort of motivates all of our biodiversity projects. But thinking about it in terms of insects, insect declines have been almost double the losses as compared to vertebrate species. There are many reasons for insects having such a high rates of decline, including nitrification, disruption caused by climate change, fire, storm intensities, global warming, droughts, pollution, urbanization, introduced species, agricultural intensification, insecticides, deforestation. So insects are very sensitive to a lot of these stressors, and I think that's why they think that these have been declining. Insects are obviously very important to food webs. They're also important in nutrient cycling and pollination and many other vital aspects to them. And then, but they're out of insects. Butterflies are some of the most studied of the insects. And this is because they're a little easier to study. They're a little more distinctive between species. They're attractive. People like them. Also, they come out during the day, which makes them easier to study. But there's they also have a scientific basis for being a good indicator of for insects. So, and by studying butterflies, we can also learn a lot about the rest of the insects. And so because they experience comparable environmental pressures from habitat degradation, climate change, and land use change. They have short cycles, so they respond quickly to abiotic changes, and they are reliant on plants as a source of nutrition. So also as plants go down, butterflies do as well. They're ectothermic, and so they're even more sensitive to climate change. Just a couple years ago, this paper came out about butterflies, showing that fewer butterflies were being seen across the American West. And something interesting about this paper was that they used NABA data. They actually used 3 different data sets, but one of them was NABA data. So as you may know, we contribute our data to NABA. NABA is the North American Butterfly Association. And so we share all of our data with them. And so it was an interesting thing to find, and they found a 1.6% annual reduction across the U.S. Western U.S. And so, but we got to thinking about this, and we were sort of ready to be starting to analyze our butterfly surveys. And Ron Rutowski and I did start some preliminary analyses, but we found that we were interested in finding out more of a context, because there's a lot of variation. We needed sort of a bigger study to look at this. So also compared to the Forrester paper that I just showed, Arizona has distinct bimodal precipitation patterns with the monsoon and the winter rains, which is different from the rest of the West. And then also precipitation had increased since the data sets that that other paper used. They cut theirs off at 2018, and after that we got some better rain. So we were wondering, if we just focus on Arizona, will we still see the same level of declines? And we wanted to know also how climate factors specifically were affecting butterfly abundance and richness. And so this is part of our monitoring. We were trying to take the results and analyze them to try to figure out our next steps. So let's see. So I want to acknowledge Ron Rutowski, who has been our butterfly partner, research partner for the butterfly surveys. He's also the NABA Central Arizona Butterfly Association president, and of course an emeritus from emeritus professor at ASU. And Gina Clark, who is our current citizen science lead for doing her work and helping keep these going. And I reached out to some collaborators on this regional project to help with the analysis. So I'd like to introduce Bradley Johnson, who will be presenting the analysis. He just graduated last week with his master's degree from ASU, from this school, and he was working under Dr. Jennifer Broach, and also at Arizona State University, professor there, and Katie Prudick, who was actually on that Forrester paper I showed before about the declining butterfly species, and she's at the University of Arizona.